So solving two-step equations where two variables are changing in a single moment, we can actually break that down and do it the same way that we did when we only changed one thing. So let's read this problem and break it down. What would be the new volume if 250 centimeters cubed of gas at 25 degrees Celsius? I'm going to immediately kind of change that over to Kelvin just as I'm reading it, just because I want to make sure that I do that. So 25 plus 273 equals 298 Kelvin, and has a pressure of 730 millimeters of mercury. It was changed to 0 degrees, so 0 plus 273 equals 273. And then it changes also to 760 millimeters of mercury. Okay, so what would be the new volume if 250 cubic centimeters of gas at 298 Kelvin and 730 millimeters of mercury of pressure were changed to 0 degrees Celsius, or 273 Kelvin, and 760 millimeters of mercury? Okay, so there's two different changes that are happening here. I'm changing my pressure, and I'm also changing my temperature. So let's just break this down. Just choose one to start with, and we're going to keep changing our volume until we're done with the problem. So let's change our pressure first. So our pressure changed from 730 mmHg, and it went to 760 mmHg. So again, pulling it out of the problem, where it started, where it ended. And then let's look at the temperature second. So the temperature went from 298 Kelvin, and it dropped to 273 Kelvin. So I'm just doing the problem twice. And my starting volume at the very beginning of all of this is 250 centimeters cubed. Now, if you like, you can cross these out. I'm not going to be using these right away, right? So these are the ones I'm not going to use. I'm going to have to find this one first, right? That's this number up here. So let's see what's going on. What's my relationship? Pressure goes up. So when pressure goes up, volume must come down. All right, there's our starting point. So we start out the same way that we do every single time. We put our number out front and over 1. We know we can pick 760 over 730, or 730 over 760, because that's the two fractions that'll create. We know it goes down, so the big number should go down. So that's 760, and 730 is on top. So when we enter this into our calculator, so 250 times 730 divided by 760 is equal to 240.1 centimeters cubed. That number, this number here, so that goes 240.1 centimeters cubed, that's going to now be my new volume down here. So this goes in here now, 240.1 centimeters cubed. I've changed one thing. Now I'm going to change the other thing. So in this case, temperature goes down. When temperature goes down, volume also goes down. So let's see what our new volume must be. So we do the same thing, 240.1 over 1. Set up my fraction. I know I can pick 298 over 273, or 273 over 298. And I'm going to pick the one that goes with the big number down, because this number has to go down. So that's 298 on the bottom and 273 on the top. And when I do 240.1 times 273 divided by 1 divided by 298, we get 219.96 centimeters cubed. Somewhere roughly around there. 220 is what I think I have in the answer key. So that's all we're doing. We're just breaking this down to do two things separately. So it really becomes exactly the same as we've done before. We're just pulling this new volume here, and we're just doing another change to it. That's it. So let's look at our last problem here. So we have a 350 milliliter sample of a gas that has a temperature of 30 degrees Celsius. So let's already change that over, 303 Kelvin, 273 plus 30, and a pressure of 1.2 atmospheres. What would the temperature be? So I'm trying to find that temperature. Would be needed for the same amount of gas. So I'm definitely not changing amounts anywhere in this problem, to fit in a 250 milliliter flask at 1 ATM. Okay, so let's start looking at what's going on here. I'm changing two things. So what am I changing? I'm changing my volume, and I'm also changing my atmospheres of pressure. Let's start with pressure. We're going from 1.2 ATMs to 1 ATM. And then what's my next change is for volume. I'm going from 350 to 250 milliliters. So I'm going from 350 milliliters to 250 milliliters. Okay, so now what's the temperature? Because that's what I want to know, is what temperature could it be for this, right? So I'm starting at 303 Kelvin. So as pressure goes down, temperature should go down, right? So we're starting there, just looking at the relationships. We're going to do our 303 over 1. We got to figure out what fraction to put here. It could be either 1.2 over 1 or 1 over 1.2. We know it should go down, so the big number should go down. And 303 times 1 divided by 1 divided by 1.2 is 252.5 Kelvin. Tossing that into my calculator. Now this 252.5 Kelvin, that's the number I got to bring down here to my next temperature. So this is my 252.5 Kelvin. So I'm trying to find this number right here. My volume went down, so temperature should go down again. So let's do it again. We got 252.5 Kelvin over 1. We have a fraction. I can choose either 350 over 250 or 250 over 350. I know that temperature has to go down, so the one with the big number on the bottom is what I choose. I pop it into my calculator, I get 180.4 Kelvin. And that's what we do. We're just breaking this down to do one thing at a time. So you'll need two PVTn tables. There are some problems where the order will matter, but most of the ones do not. Really what we're looking for is this. I want to see that you're breaking these down into two pieces. I know that I'm changing the volume, and I know that I'm changing the pressure. So the first one I'm going to change one of the two, right? It doesn't matter which one you start with. But you're going to put those in, change your temp, put your next change in, and then change the temp again. So that's what we're looking for. So take a step-by-step approach and use the same methods that we did with the single step, and you'll still come up with the same answer. All right, thank you very much.